What's going on, everybody? Back for another video. This one is motion in space, velocity and acceleration. So, it's a new lesson, but it's not the concept. It's really not anything different than what you've been doing. You've got a position vector, a velocity vector, and acceleration vector. And you can see r of t is going to be the position vector at time t, velocity, v of t is the velocity vector at time t, and the velocity is the derivative of the position vector. And then you've got a of t is the acceleration vector at time t, and acceleration is the derivative of the velocity, and it's the second derivative of the position. And then the magnitude of the velocity is the speed of the particle at time t. And as you've learned in past lessons, the magnitude of the velocity is just the magnitude of the position vector, r prime of t, which is ds dt. All right, so let's look at some examples, and we've got several examples to work in this video. All right, so let's see. We've got the position vector of an object moving in a plane is given by r of t is equal to t cubed times vector I plus t squared times vector j. Let me make that 3 a little bit better. All right, find the velocity, speed, and acceleration when t is equal to 1. All right, so we've got the velocity vector, which is the derivative of r, the position vector, and so that's just 3t squared times vector I plus 2t times vector j. And there's your velocity vector. And I guess let's just go ahead and find the acceleration vector. So the acceleration vector, that's equal to the derivative of the velocity vector. So we're going to take the derivative of this one. So that's 6t times vector I plus 2 times vector j. And there's your acceleration vector. And then we want to find the speed. So that's the absolute value, or not absolute value, that's the magnitude of the velocity vector, which is 3t squared plus, so we're doing the magnitude of this, plus 2t squared, and it's the square root of all that. And so this is just equal to 9t to the 4th plus 4t squared. And there's your speed. Now, they want us to find the velocity, speed, and acceleration when t equals 1. All right, so that's just going to be v of 1, right? V of 1 is, so we're going to plug the 1 in, so that's 3 times 1 squared times vector I plus 2 times 1 times vector j, which is 3i plus 2j. And there you have it. Okay, and then the acceleration at time t equals 1, that is going to be, we're going to plug 1 into there, so that's 6 times 1 times vector I plus 2 times vector j, which is 6 times vector I plus 2 times vector j. And then they want the magnitude, or they want the speed at t equals 1. So all that is, that's just finding the magnitude of this one right here. So that's going to be 3 squared plus 2 squared, the square root of that, which is equal to the square root of 13. All right, so that should be easy enough for you there. I mean, it's just like what you did before when you were in probably Calculus 1, when you had a position function and the derivative of that was the velocity. Derivative of velocity was acceleration. Same thing. We've got vector functions, though. That's the difference. All right. All right, so let's look at this. Find the velocity, acceleration, and speed of a particle with position vector r of t. All right. All right, so we've got r of t is equal to t squared e to the t, t e to the t. So it's the same thing as the other one. They're just not asking us to, they're not asking us to evaluate it at t equals 1, and instead of writing it in this ij or ijk form, they're writing it here with the components. All right, so we've got the velocity, which is the derivative of this. So that's going to be 2t e to the t. I'm just taking the derivative of each one. And now here, remember, you got to do the product rule. So that's the derivative of the first function times the second function plus the derivative of the second function times the first function. And so I guess we'll just write it right here. B of t is equal to 2t e to the t, and then e to the t. Well, it don't matter how we factor it out. Let's write 1 plus t e to the t. It doesn't matter if you write the e to the t before or after that. It doesn't matter. So this would be your velocity vector. And then a of t, well, that's just the derivative of this thing right here. So that's going to be 2 e to the t. And then here we use the product rule. So this is our first function. This is our second function. So it's the derivative of the first function times the second plus the derivative of the second times the first. And so we get a of t is equal to 2 e to the t. Factor out e to the t. That's going to be 1 plus t times e to the t. See, all I did is I just factored this e to the t out. And so this is going to give us acceleration is 2 e to the t and then 2 plus t times e to the t. And there's your acceleration. All right. Oh, we're running out of room there on a... All right, so now let's find the speed. All right, so our speed, that's going to be the magnitude of the velocity. So each one of those I'm squaring, so that's going to be 2t squared plus e to the t squared plus 1 plus t e to the t squared. And it's the square root of all that. So I end up with 4t squared plus e to the 2t, remember, multiply exponents, plus 1 plus t squared e to the 2t. And then we've got the square root of all that. And there's my answer. Just leave it like that. That's good enough. All right. So, not bad at all. That's pretty easy, pretty straightforward. All right. Now let's look at this one. So it says a moving particle starts at an initial position. R of 0 is equal to 1, 0, 0 with initial velocity. So it's giving us the initial position and it's giving us the initial velocity. Its acceleration is a of t, so we're going to need that. We've got a of t is equal to 4t I plus 6t j plus k. Find its velocity and position at time t. All right, so if we have an acceleration, to find the velocity, what do? Well, we integrate the acceleration function. So I've got the velocity is equal to the integral of the acceleration function, which that's going to be the integral of 4ti plus 6tj plus k dt. All right, so let's go ahead and integrate that. So that is going to give us 2t squared times vector I plus 3t squared times vector j plus t times boy, did I mess up. Not thinking. So that is 2t squared plus, remember it's plus a constant, so we'll name this constant C1 times vector I plus 3t squared plus C2 times vector j plus t plus C3 times vector k. All right, so there we have it integrated. Now, they give us a condition that says v of 0 equals that. So if I plug 0 in for t, it should equal this. So I have v of 0. Let's see. Well, I'll do it right here. V of 0. So notice if we plug 0 into here, I end up with just C1. Plus, and if I plug 0 into here, I end up with C2. And then if I plug 0 in for t here, I end up with C3. And that should equal this, I minus j plus k. And so what this tells me is that C1 is equal to 1, C2 is equal to negative 1, and C3 is equal to 1. You see that? See, the number in front of I has to equal this number in front of I. The number in front of j has to equal this number in front of j, and the number in front of k has to equal that number in front of k. And you know this is understood to be a 1, that's negative 1, and that's 1. So my velocity is equal to 2t squared plus 1, now I'm just plugging these in to here, times vector I plus 3t squared minus 1 times vector j plus t plus 1 times vector k. And that is your velocity vector. All right, now they want us to find the position. Yep, we got enough room. All right, so now I have r of t is equal to the integral of the velocity vector. So that's equal to the integral of this thing. So that's 2t squared plus 1 times vector I plus 3t squared minus 1 times vector j plus t plus 1 times vector k. Okay, and that is integrated with respect to t. All right, so let's integrate this. So this is going to be 2/3 t cubed plus t. I'm integrating this plus our constant. Now, notice up here we use C1, C2, C3. So let's just use a different letter. Let's use, say, D. So we'll call that D1. Okay. And and that's times vector I, plus, and then that's going to be 2 cubed minus t plus d2 times vector j, plus, and then that's going to be 1/2 t squared plus t plus d3 times vector k. All right. All right, so now that we integrated it, now notice we have this r of 0 is equal to 1, 0, 0. And let's just write that down here, that r of 0 is equal to 1, 0, 0. Make sure I copied that down right. Yep. All right, just so we can see it. All right, so I have r of 0 is equal to, so I'm going to plug 0 into here, and that's just going to give me d1 times vector I, plus plug 0 into here, that's going to give me d2 times vector j, plug 0 into here, that's going to give me d3 times vector k. And that should equal this vector. So that's going to be equal, well, basically it's just equal to I. Now what we can do, and you don't have to do this, but we can write this 0 times vector j plus 0 times vector k. And so you can see that this means that d1 is equal to 1, d2 is equal to 0, and d3 is equal to 0. See, the d1 has to equal 1, the d2 equals 0, and the d3 equals 0. And so now I've got r of t is equal to 2/3 t cubed plus t plus 1, see, d1 is 1, times vector I, plus, and then we've got t cubed minus t, and then d2 is 0, so that's times vector j, plus 1/2 t squared plus t, and then d3 is 0, so then that's times vector k. And there's your position vector. All right, so that's not too bad. Okay. All right, let's just move right along. All right, so we've got Newton's second law of motion, and we have parametric equations of the trajectory r. X is equal to v0 times cosine alpha times t. Y is equal to v0 sine alpha times t minus 1/2 g t squared. And then d is the value of x when y is 0. That's your distance right there. And t equals 0, or t equals 2v0 sine alpha over g. And all that is that this right here came from taking this and solving, setting this equal to 0 and solving for t. And then d is equal to x, which is v0 squared times sine 2 alpha over g. And d has its maximum when sine 2 alpha is equal to 1, which means that alpha is equal to 45 degrees. All right, so let's do an example, and we're going to use this to work the example. All right, so our example here, it says a projectile is fired with muzzle speed 150 meters per second and angle of elevation 45 degrees from a position 10 meters above ground level. Where does the projectile hit the ground and with what speed? All right, so what do we have to do here? Okay, so they want to know, where does it hit the ground? All right, so that's, how do we find that? Okay, how do we find that? Well, that's the x value, right? That's where it hits the ground. And then how do we go about finding that? Because we need a value for t. We need to know, when does it hit the ground, right? When does it hit the ground? And then we take that time and we plug it in for t, and that will give us x. Okay, so that's when it will hit the ground. And then it wants to know with what speed. All right, so these are the parametric equations for, see, like we talked about up here, parametric equations of the trajectory. And I moved these. I had them written here, but I moved them down here so we could see them. All right, so with what speed? So to find the speed, we need a velocity vector, right? And then we take the magnitude of that velocity, and that will give us the speed. Well, to do that, to get the velocity, shouldn't we find the position vector? All right, and that's going to consist of x and y. So basically what we need to do is just plug all this information into here. So I've got x is equal to 150 times cosine 45 degrees times t, right? See, v naught, that's 150, and then alpha, my angle, is 45 degrees. And so this is going to give me, well, cosine of 45 is square root of 2 over 2, 150 over 2, that's 75 square root of 2 times t. And then I have y is equal to, now I'm leaving a little space here, you'll see why, 150 times sine 45 t minus 1/2, and what's g? That's 9.8 t squared. All right. Now, where are we starting? Is y starting from the ground level? No. See, at t equals 0, all right, so think about this. Our initial position is 0, 10, right? So when t is 0, I've got 10 as an answer. So wouldn't I just add 10 to the front of that? And that'll give me my y, my y component, because the initial position is 10 meters above ground level. All right, so this is going to give me y is equal to 10 plus, and this is square root of 2 over 2, square root of 2 over 2 times 150 is 75 square root of 2 times t minus, and then this is going to be 4.9 t squared. All right, and so there's x, there's y. All right, now when does this thing hit the ground? Isn't that what we need to find? We need to know at what time does this hit the ground. So it impacts or hits the ground when y is equal to 0, which means 10 plus 75 square root of 2t minus 4.9 t squared equals 0. And so this would tell us t is equal to 21.74. So you'll get two answers. One will be a good answer, one won't. So how do we get that answer? Well, obviously, you know, quadratic formula. You should, if you're in this class at this point, you should know how to do the quadratic formula. I'm not going to go over it. All right. So now we can find x, that's our distance, right? It says d is equal to x. So we take the 21.74 and plug it into here. So that's 75 square root of 2 times 21.74, and that is about 2,306 meters away. All right, so that's what we were looking for there. All right, now let's find the speed at impact. So let's get our position function. our position vector. So we've got r of t is equal to 75 square root of 2t times vector I plus 10 plus 75 square root of 2t minus 4.9t squared times vector j. So there's our position vector. Well, what do we need? We need the velocity vector. So the velocity vector is just the derivative of this. So that's 75 square root of 2 times vector I plus, and then that's 75 square root of 2 minus 9.8t times vector j. All right, so what do we need? We want the speed at impact. So the speed when it hits the ground. Well, that's just the magnitude of the velocity. So, well, let's rewrite that. The magnitude of the velocity when it hits the ground. So I did write v of t, but that should be v of 21.74, right? Because that's when it hits the ground at that time. And so this is going to be 75 square root of 2 squared, right? It's this squared plus this squared plus 75 square root of 2 minus 9.8 times 21.74. I'm replacing the t with the 21.74, and that's squared. And then we've got the square root of all that. And so that's about 151 meters per second. And there's your answer. So you can see that's not bad. Not bad at all. All right, so let's look at the next thing. This is the last thing here. We've got this, and then we've got one more example to work, and we will be done. All right, tangential and normal components of acceleration. So we can take the acceleration and break it up into its components. So v is the magnitude of the velocity. Okay. I've got vector A is a sub t times vector t plus a sub n times vector n. Vector t, we talked about this in a previous lesson. That's the derivative of r over the magnitude of the derivative of r. The derivative of the position vector divided by the magnitude. N of t is t prime, vector t prime divided by the magnitude of vector t prime. A of t, this and this, A of t is the derivative of v. Now, not the derivative, okay, not the derivative of vector v, but it's the derivative of v, the derivative of the magnitude of v, of vector v. And then a sub n is, what is that? The curvature times v squared. Or, well, and then remember, if you take this, the curvature, remember, is this formula. So you can actually simplify it a little bit. Remember, v squared, that's going to be the magnitude of the velocity squared, which is also what? The magnitude of r prime squared. So if you got the magnitude of r prime squared times this, say you've got the magnitude of r prime squared, it's going to cancel that, and you're left with just one of those in the denominator. Okay, so that's the way you can do that. All right, so let's look at an example. All right, so it says a particle moves with position function r of t equals t squared, t cubed. Find the tangential and normal components of acceleration. All right, so what are we looking for? We're looking for a of t and a sub n. That's what we're looking for. So look at what all we have to find. The derivative of r and the second derivative of r. We need the magnitude of r prime, and we need the magnitude of the cross products. Okay. All right. So let's see. Let's write down r. So we've got r of t is equal to t squared, t cubed. And so we have r prime of t is equal to 2t, 3t squared. And then we've got r double prime is equal to, and I tell you, let's do this. Let's do this. I'm sorry. If you're taking notes, I apologize for you having to erase a little bit. Let's do this as t squared I plus t squared j plus t cubed. Okay, let's write it in ijk form because we are going to take the cross product, so we'll get a solution in ijk. So we've got r prime of t, and I guess we'll go ahead and write this as r of t. So that's going to be 2t times vector I plus 2t times vector j plus 3t squared times vector k. And then r double prime of t is 2i plus 2j plus 6t k. All right. And then what else do we need? We need the magnitude of r prime, don't we? So the magnitude of r prime is equal to the square root. So here's r prime. So it's this squared, 2t, all of that squared. So that's 4t squared. 2t, all of that squared, 4t squared. And then 3t squared, all of that squared. So that's going to be 9t to the fourth. And so I get the square root of 8t squared plus 9t to the fourth. Now, let me clean that up some. All right. So there's the magnitude. So now from that, well, we can get the tangential component. What is that? That's the derivative of v. You see that? Well, did we find v? Yeah, that's the magnitude of the velocity vector. Isn't this the velocity vector? This would be the magnitude of the velocity. So this is actually, we could write v equals that. So we need the derivative of this, don't we? What in the world is the derivative of this? Okay, so if you've watched some of my other videos, you know I have a little shortcut for the derivative of a square root function. So how do we take the derivative of a square root? So we're taking the derivative of this. Let's write it. V equals the square root of 8t squared plus 9t to the fourth. This is what we're taking the derivative of. So whenever you're taking the derivative of square root, it's 2 times whatever that square root is. Okay? That goes in the denominator every time. And then what goes in the numerator? The derivative of what's underneath the radical. So that's 16t plus 36t cubed. And so this is going to give us 8t plus 18t cubed over the square root of 8t squared plus 9t to the fourth. There's your tangential component. Okay, so we found that. That's not bad. Now, what do we need to find? Now we want to find the normal component. So to find that, well, what am I gonna do there? I am going to find this. So I need the cross product of the first and second derivative. All right, so I've got r prime of t cross r double prime of t. So that's I, j, k. And that is going to be, let's see, 2t, 2t, 3t squared, 2, 2, 6t. All right. All right, so now we've got, let's see, so I'll kind of work through this. So I've got what? I've got 12t minus, well, I got 12t squared minus 6t squared. You see that? So that is 6t squared times vector I. And you should know how to do cross products. All right. Minus, remember the sign changes. So I've got 12t squared minus 6t squared. So that's going to be 6t squared times vector j. All right, and now we're going to knock out this one. So that's going to be 4t minus 4t. Well, that's 0. You see that? So there's your cross product. And what do I need? I need the magnitude of that cross product. So that's going to be the square root of this squared, 6t squared, all of that squared, that's 36t to the fourth, plus, and then what is this? That's minus 6t squared, all of that squared, so that's 36t to the fourth, which that is the square root of 72t to the fourth. So that's going to give us 6 square root of 2 times t squared. And so now a sub n is the magnitude of the cross product, which is 6 square root of 2 t squared over what? Basically, that's over v, right? See, there's our magnitude, v. So that's square root of 8t squared plus 9t to the fourth plus 9t to the fourth. And there's your normal component. And that is it. That's all of this lesson. So I hope you learned something. I hope you feel a little bit smarter after watching this video. I appreciate you watching. Check out my other videos. Give me a like, share, subscribe, comment. And I will see y'all in the next one. Later.